Today we will be looking at Chapter 7, Lesson number 3, and today we'll be dealing with triangles. So in today's lesson, we want you to be able to construct triangles with given angle measurement, and we also want you to be able to construct triangles with given side length. And to construct means to draw. One thing to remember with triangles is that all three angles in a triangle always add up to 180 degrees. Anything more than 180 degrees or less than 180 degrees will not create a triangle. Before we can construct triangles, we need to review 4 key terms based on angles. An acute angle is an angle that measures less than 90 degrees. A right angle equals 90 degrees. An obtuse angle is an angle that is greater than 90 degrees and is less than 180 degrees. And a straight angle equals 180 degrees. The 3 angles we will be looking at today are the acute angle, the right angle, and the obtuse angle. There are 2 main ways of classifying triangles. One way is classifying them by their angle measure, and the other way is by classifying by the length of their sides. So the first way we're going to take a look at is classifying triangles by using their angles. So, when classifying a triangle using its angles, there are 4 ways that we can classify a triangle. If the angles of a triangle are acute, meaning all 3 angles are less than 90 degrees, we would call that an acute triangle. So if I have my protractor and I measure these angles, each angle measures less than 90 degrees. And because of that, we classify that as an acute triangle. The second way we can classify a triangle by its angles is calling it an obtuse triangle. An obtuse triangle has 1 obtuse angle. It cannot have more than 1 obtuse triangle or 1 obtuse angle, but just 1. So let's take a look. I put my protractor down here, I put the vertex, and if I look at this, I measure this angle, and it's approximately 108 degrees. All right. So because there's 1 angle that's obtuse, greater than 90 degrees, we classify this triangle as an obtuse triangle. The third type of triangle that we can classify by using its angle is a right triangle. A right triangle has 1 right angle. It can't have more than 1 right angle, just 1. And again, if we notice, we see the red square, and that lets us know that that's a 90-degree angle, and we don't have to measure it, but we could just to show where this right angle is. Since it has 1 right angle, we would classify that as a right triangle. The fourth classification of a triangle using its angles is called an equiangular triangle. Equa for equal, so that means it has equal angles. Remember, congruent is a fancy math term for equal, so this has 3 equal angles. Now, if we look at our key down here, the red arc indicates congruent angles. So once we see these red arcs, that lets us know that each of these 3 angles, each one of them is equal. So, 4 ways of classifying triangles using their angle measures. An acute triangle has angles that are all acute. All three angles have to be acute. All three angles have to be less than 90 degrees. An obtuse triangle is one of the three angles is greater than 90 degrees, so it's an obtuse triangle. The third type of triangle that we can classify is a right triangle, and it has one right angle within the triangle. And finally, the fourth triangle is an equiangular triangle, meaning all three angles are equal. The second way that triangles can be classified is by their side length. We need to remember that congruent sides have the same length. Remember, congruent is a fancy word for equal. Again, looking at our key down here, red tick marks indicate congruent sides. So when we get to these right here, this means that these two sides are equal. This one is not because it doesn't have a red tick mark. These three sides are equal because it has a red tick mark. All right, so let's look at the three types of triangles, how they're classified by using their side length. The first triangle is a scalene triangle, and a scalene triangle has no congruent sides. So that means each side is a different length. No sides are the same measure. The second type of triangle is an isosceles triangle. An isosceles triangle has at least two congruent sides. So when we see here, this side is congruent or equal to the length of this side. So this is an isosceles triangle, at least two congruent sides. The third triangle, classified by side length, is an equilateral triangle. Equa meaning equal, equal sides, equilateral triangle. And here, all three sides are congruent. You'll notice the red tick marks. And again, this indicates that this side, and this side are all congruent. They are all equal. They all have the same measurement. So, the three types of triangles based on side length: scalene triangle, which has no congruent sides; the isosceles triangle, which has at least two congruent sides; and finally the equilateral triangle, where all three sides are congruent or all three sides are equal. I really encourage you to turn to page 284 in your math book. And on this page, there is this chart that you just saw that shows the different ways to classify triangles using angles and side lengths. So we'll be referring back to this quite often, and it helps you use this as a guide to when you decide to classify the triangles by their angle and side length. You will be asked to classify triangles that are given to you. In this first diagram, we see a triangle that has angle measures, and it also takes a look at its side lengths. So I have my chart here to help me decide how am I going to classify this triangle using angle measures and side lengths. So the first thing we want to do is determine how we're going to classify it using angle measurements. So I notice that each angle is 60 degrees, and they're also all three less than 90 degrees. So as I go through, I do think it could be classified as an acute triangle because each angle is less than 90 degrees. It cannot be classified as an obtuse triangle because no angles measure more than 90 degrees and less than 180 degrees. I can't classify it as a right triangle because there's no angles in here that equal 90 degrees. The last one, equiangular triangle, does it have three congruent angles? Well, it's 60 degrees here, 60 degrees here, and 60 degrees here, so it is an equiangular triangle. So it's an acute triangle and an equiangular triangle. Now, because we know in order for them to all be equal, they all have to be acute as well. So in this case, an equal angular triangle would also have all acute angles, so we would refer to it as an equal angular triangle. So the first way we're going to classify this is calling it an equal angular triangle. So it's an equal angular based on angle measurements. Now we need to go down to classifying the triangle using side lengths. And remember, again, congruent sides have the same length. So when we take a look at the side lengths, the first thing that I notice it has 3 tick marks on there. So that lets me know that this side is equal to this side, which is also equal to this side. So all 3 sides are the same length. And I look at the 3 ways that I could classify a triangle based on side lengths. Well, a scalene triangle has no congruent sides, meaning no sides are equal. That's not the case here. These 3 sides are all equal. An isosceles triangle has at least 2 congruent sides, and an equilateral triangle has 3 congruent sides. And if I take a look here, all 3 sides are congruent or equal. So this would make this an equilateral triangle because all 3 sides are congruent. So classifying it based on side length, it would be equilateral. So angle measurements is equal angular, side length is equilateral. So our official classification title for this triangle would be equal angular, equilateral triangle. All right, looking at example number 2, we're going to classify this triangle again by its angle measurement and by its side length to come up with a formal classification name. So, again, using our guide that you can find on page 284, looking at the angle measurements, I've got a 32-degree angle, a 128-degree angle, and a 20-degree angle. So right off the bat, I know it's not an acute triangle because they are all 3 angles. They're not all less than 90 degrees. All right, one of them is more than 90 degrees. Obtuse triangle. It has 1 obtuse angle. And again, an obtuse angle is greater than 90 degrees, but less than 180 degrees. And right here I see that it's 128 degrees, which lets me know, you know what, I think that's going to be an obtuse triangle. But let's continue to make sure. Right triangle, it has to have 1 angle that's 90 degrees, and that's not the case here. And an equal angular triangle has 3 congruent angles. Well, these 3 are not equal numbers. 32 does not equal 128, and that doesn't equal 20. So I look at this and realize this is an obtuse triangle based on angle measurement. So for the angle, I'm going to write down obtuse. Now I'm going to classify it based on its side lengths. All right. Well, I don't see any tick marks, so that doesn't help me out thinking that any of them are the same measurement. But I may have to refer to a ruler to help me determine the lengths of these sides. They all look different sides, but I'm just going to check to make sure. Okay. So the bottom measure is a little bit more than 1.5 inches. This side length is 2.5 inches. And this third side is a little bit more than 3.5 inches. Now, I could kind of tell that just by looking at it, but I measured it just to make sure. So no sides have any of the same measurement. They're not congruent. So if there's no congruent sides or no sides that are equal, it is a scalene triangle. Now, if it had 2 equal sides, we'd see tick marks, or if we saw 3 equal sides, we would see 3 tick marks. So I think it's good to check for your measurements, but this would be a scalene triangle based on no sides have the same measurement. So our official classification title of this triangle would be an obtuse, scalene triangle. All right. On example number 3, I'm sure immediately you notice that there is a right angle within this triangle. So when we take a look, right away we know it can't be acute because acute is less than 90 degrees. There's no obtuse angle because nothing is greater than 90 degrees or less than 180 degrees. But right away we noticed that there was a right angle in there. And again, we see that square that is put there to indicate that it's a 90-degree angle. So right off the bat, we can classify this as a right angle. Now, looking at its side length, we need to take a look. Scalene, no congruent sides. Isosceles, at least 2 congruent sides. Equilateral, meaning all 3 sides are congruent. Well, in this particular case, we notice that no sides are the same length. So this would make this a scalene triangle because no congruent sides. So the formal classification of this triangle would be a right scalene triangle. Now, one thing I want to do is at the beginning we talked about that all triangles have to add up to 180 degrees. So let's just check to make sure that this triangle does add up to 180 degrees. Well, here we know that that's a 90-degree angle. We know that this is a 72-degree angle. And we know that this is an 18-degree angle. So if we add those 3 angle measurements up, it should add up to 180 degrees. 8 plus 2 is 10. We carry our 1. 9 plus 1 is 10. Plus 7 is 17. Plus 1 is 18. And all 180 degrees are accounted for. All right. For our 4th example, let's take a look at this triangle. So first of all, classifying by its angle measurement, we have an acute. All angles are acute. Less than 90, less than 90, less than 90. Is it an obtuse? Nothing is greater than 90 or less than 180 degrees. We do not have a right angle, and they are not equal. 2 of the 3 are equal, but not all 3 of them. So in this particular case, they are all acute. They are all less than 90 degrees. So the angle classification will be acute. Let's move on to classifying by their side lengths. Now, right off the bat, I notice that we have 2 tick marks. Though this is to indicate that this side is congruent or equal to this side. So these 2 sides are equal. Now, if this side was the exact same measurement, we would see that they would put a tick here, but they did not. So we know that 2 sides are congruent or 2 sides are equal. And if we look at our classification guide here, no congruent sides, well, we know that 2 are the same. At least 2 congruent sides, which would be isosceles. Now, if all 3 were congruent, it would be equilateral, but that's not the case. 2 congruent sides is an isosceles triangle. So the classification based on angle measurement is acute. The classification based on side length is isosceles. So the formal classification of this triangle would be an acute isosceles triangle. Now again, just to clarify, does this triangle add up to 180 degrees based on its angle measurement? So we'll do a quick check. So 5 plus 5 is 10. I'm going to carry my 1. 6 and 6 is 12. Plus 5 is 17. Plus the 1 that I carried would be 18. And yes, it does check out that this triangle does have 180 degrees. Now I'm going to give you one to try on your own. And what I'd like for you to do at this moment is classify this triangle. And again, I want you to take a look at it based on its angle measurement and its side length. So what I'd like for you to do now is to hit the pause button and classify this triangle. All right. Due to the fact that it has a right angle within the triangle and that it has two congruent sides based on the tick marks, this triangle would be a right isosceles triangle. Nice job. Here's another triangle I'd like for you to try on your own. Notice that there are some different signs, the tick marks and the arc measures, to help you out when solving this triangle. I am going to have you hit the pause button again for you to try this out on your own. All right. As you noticed, first of all, by looking at all of the angle measures, we see these three arcs, which lets us know that each of those angles has the same measure. So based on our chart here, we see right away that it has three congruent angles, which makes it an equiangular triangle. Now, looking at the side lengths, we have three tick marks. That lets us know that this side, and this side are all congruent or all equal. So again, as we look at our chart here, equilateral triangles have three congruent sides. So it's an equilateral triangle. So the formal classifying name of this triangle would be an equiangular equilateral triangle. At the beginning of this video, the one thing we wanted you to be able to do was to construct triangles with given angle measurements. Well, here is where that will take place. So you are asked to draw a triangle with the given angle measures. All right? So this is where it gets to be a little fun, where we get to start drawing some angles. Don't be afraid to draw these angles big. You don't have to be small. It's all right if they overlap and get big. So the first thing I'm going to do is I'm going to take a look at which angle is the most familiar to me, which might be the easiest to draw. And right off the bat, 90 degrees stands out to me. So I'm going to use my protractor, and I'm going to start with just my base. And there's my vertex, all right? And it's all right if you draw your lines too long, and I'll show you what that means here in just a second. So the first thing I'm going to do is I'm going to create a 90-degree angle. So I'm going to line my vertex up. I'm going to make sure my ray goes through 0. Again, 0, 10, 20. I look and it goes through. And I'm going to measure my 90-degree angle. Okay? So I've gone up to 90 degrees, 10, 20, 30, 40, 50, 60, 70, 80, 90. So I'm going to line the vertex and that line up. All right, so there is a 90-degree angle. Put this here. Okay, so I've taken care of my 90-degree angle. Now I'm going to draw a 65-degree angle. Now, what side I choose to go on, it doesn't matter. But what I'm going to do is I'm going to go on this line, and I'm going to angle my measure up this way, 65 degrees. All right. So I'm just going to put my protractor on this line, but I need to see first off where 65 degrees is. I know my angle is opening up this way, so I'm going to start with the outside measurements. So 10, 20, 30, 40, 50, 65. So 65 is going to be right there. And I have to take a look. If I start my angle here, will it cross that line? And I think it might go a little bit too far. So I'm going to slide this in. And again, you can see where that 65 mark is. if I were to put my vertex somewhere in this area, it's going to cross. So this is what I'm going to do. I'm going to put my vertex point right there. Make sure it goes through 0. And I'm going to make that 65 mark right there. So hit that there. Now, I'm going to go back in and check. Make sure the vertex and the line go through 0. And I take a look, that line goes right through 65. All right, so I've done the 65. Now, my triangle is complete. All right, but we know that if we have these two angles, and this is 90 degrees, and this is 65 degrees, there's only one amount of degrees that this could be, based on that we know that all triangles add up to 180 degrees. So let's just do some math here. If we take 180 degrees that's in every triangle and we subtract the 90 degrees from right here, we would have 90 degrees left over. Now let's take the 65 degrees away. So we're going to take that. 10 minus 5 is 5. 8 minus 6 is 2. So we have 25 degrees left. So if I take my protractor, put that on the vertex, make sure that goes through 0. Take a look. There's 10 degrees, there's 20 degrees, and take a look. That line goes right between 20 and 30, and it's 25 degrees. So that angle measure is 25 degrees. When you construct a triangle, you only have to draw 2 of the 3 angle measures as long as those lines intersect, and you will get the proper amount of degrees. So a 90-degree angle, a 65-degree angle, and a 25-degree angle. Now, we need to classify this. All right. So based on what we just did, let's use our information here for us to classify this. And I'm going to refer back to my little sheet that I have here. All right. The angle measures, okay, they're not all acute. But again, I notice right away, hey, there's a right angle within this triangle. So we know that it's a right angle measure. Now, side lengths, okay, we created this, all right, so there's no tick marks that are given. I could quickly go through and measure this, all right, again, about 1.5 inches, just a little over 3 inches, it's more than 3 inches, and this is about 3.5 inches. So no sides are the same. So if no sides are the same, it's a scalene triangle based on side lengths. And the more you construct triangles, you'll find out if each angle has a different measure, no sides can be congruent. But when you start having 2 angles that have the same measure, you'll notice something about the side lengths. And if all 3 angles measure the same, you'll notice something about the side length. And I'll let you discover that the more we construct triangles. So the official classification of this triangle that we constructed would be a right scalene triangle. All right. Again, we're going to construct a triangle that has given angle measurements. And this particular triangle has a 45-degree, a 60-degree, and a 75-degree angle. So like I did last time, I'm just going to start with the vertex. And a ray. So I could pick any one of these 3 angle measures, and I generally like to start with the largest angle, so I'm going to start with a 75-degree angle. So I'm on my vertex point here. My ray goes through 0, and I'm going to go up to 75 degrees. So inside measurement, 10, 20, 30, 40, 50, 60, 70, and it's 75. So I need to go between 70 and 80. And my line's up there. And again, don't worry that these lines are long. Okay, I think it's better to have too long of line than too short of a line. So you're noticing I'm gonna draw it quite a bit bigger than probably you would originally think that you would. So there's my 75-degree angle. And I think it's important to label that just to keep track of the angle measures that you have so far. Now I can do a 60-degree angle measure or a 45-degree angle measure. And I'm just going to set my protractor on the line here, and I'm going to take a look. Well, I know a 45-degree angle, again, I'm going to work on this side here, is going to need to cross here. So I'm going to, just to kind of make this triangle a little bit bigger, notice how I'm sliding my protractor on this ray that starts getting me, notice where this intersecting point is going to be between the 40 and 50, because I'm going to need to have a 45-degree angle. All right, so I think what I'm going to do is I think it looks good. I'm going to put my vertex right here. All right, and when I put that there, again, I'm going to line it up on 0. I'm going to do a 45-degree angle, so it's opening this way, so I use my outside measurements. So 10 degrees, 20, 30, 40, 45 is right here. Okay, so I'm going to line my vertex up. Okay, so there's my triangle. Don't worry that these lines go beyond. There's nothing wrong with that. If you choose to erase them, fine, but you do not need to. So I know that this angle measure is 45 degrees. Okay, now if we take our 180 degrees, the total angle measure in here, subtract 75 and subtract 45, we would have 60 degrees left. So this angle measure should be 60 degrees. So let's set our protractor up and see if this angle is 60 degrees. So I'm going to measure this angle. I'm going to measure this angle right here. So on this vertex point, if I take a look, right, I'm getting my everything lined up. Okay, if I take a look at this line, it goes through 60 degrees. If you look right there, you've got 60 degrees. So we can verify that that is 60 degrees. And again, I'm going to restate this. As long as you have 2 angles drawn, the third angle will always be accurate as long as your first 2 drawn angles were accurate. So I did a 75 and a 45 and came up with the 60. I could have drawn the 75 and 60, and the angle that I wouldn't have to draw would be the 45. Okay, so let's classify this triangle now. And again, I'm going to use my sheet. All right, so the first thing that I noticed based on angle measurement is none of the angles are the same measure. They're all acute. All right, so I've got a 75, a 60, and a 45. So I don't have an obtuse, I don't have a right, and they're not all the same measures. So this first angle classification will be acute. The side length, again, as I do this more and more constructing, I'm going to notice that when the angles aren't the same measure, we're going to find some things out about the side length. So again, I'm going to just measure it because I don't have tick marks because I constructed this. So this angle is about 2 3/4 inches. This side length is 3 inches. And this side length is roughly 2 1/4 inches. So 2 1/4, 2 3/4, and 3 inches. No sides are congruent. They all have a different measurement. And when they do not have the same measurement, they are not congruent. They are scalene. So the formal classification of this triangle that we constructed based on angle measurements would be an acute scalene triangle. At the beginning of this video, you were also told that you will be able to construct a triangle with given side lengths, and that's what we're going to be doing now. Looking at the directions, it says draw a triangle with the given description. They give you the side lengths of 2 of the 3 sides of a triangle. One side length must be 8 centimeters, and the other side length must be 8 centimeters. And I'm going to show you that not all triangles are going to look the same, but you still may have the same side lengths. So let's take a look. So the first thing I'm going to do is I'm going to draw the side length that's 8 centimeters. So I'm going to start with my vertex, and I'm going to draw an 8 centimeter line. And on my protractor, you'll notice that the centimeters are on the inside. Inches are on the outside, centimeters are on the inside. So I'm going to line up my vertex with the 0. And that is an 8 centimeter line. Okay. Now I'm going to draw a 5 centimeter line with the vertex here. And the side length needs to be 5 centimeters. Okay. So vertex is at 0. I'm going to go to 5 centimeters. And again, I'm going to immediately label it so I know that that's 5 centimeters. Okay. So there are our 2 sides of a triangle, and to complete the triangle, all you need to do is connect the 2 endpoints. So we're going to connect this endpoint to this endpoint, and there we have a triangle with side lengths of 5 centimeters and 8 centimeters. All right, we have constructed that triangle. Now I'm going to draw another triangle, again using these 2 lengths, and we'll notice how the triangle can look differently, but yet still follow the rules of having an 8 centimeter and a 5 centimeter side length. So again, I'm going to draw my vertex. And I'm going to draw my 8 centimeter side, my other side length with 5 centimeters. So I'm going to line up the 0 with my vertex. That was 5 centimeters. Now the last thing I need to do is just connect the 2 endpoints. And there we have a triangle that has a 5 centimeter and an 8 centimeter side. So unless they give you an angle measurement, this triangle can look many different ways. I'm going to take a look at drawing a third one right now. Again, quickly. Eight centimeters. Five centimeters. Again, a triangle that has a side length of an 8 centimeters and a 5 centimeters. Now I have an obtuse triangle. So again, unless they give you an angle measure, this is a way to construct a triangle with given side lengths. All right, we are asked to draw a triangle with the given description. It needs to be a right triangle with 2 congruent sides. All right, so the first thing I'm going to do is, since it's a right triangle, I know I need to have a right angle in it. So I'm going to start with my vertex, and I'm just going to draw a ray coming out of my vertex. That'll be the base of my triangle, and it needs to be 90 degrees because it's a right triangle. I am not worried about how tall this triangle is right now. I am going to make sure I make note that this is a right angle. Okay, so it's a right triangle with two congruent sides. All right, now again, I've told you before, I don't care how long your lines are that you've drawn, but I'm going to have two congruent sides right now. So I'm just going to set this ruler down, and I'm going to make my sides 3 inches in length. And if you take a look at my ruler, 1, 2, 3, I'm going to put a little mark at the 3-inch mark. I'm going to do the same thing here. I line it up with 0. So 1 inch, 2 inch, 3 inches. There's my 3-inch line. All I need to do now is connect these 2 points. All right, because I know that this is 3 inches. From the vertex to that mark is 3 inches. From the vertex to this mark is 3 inches. So there is my 2 congruent sides. I can put a tick mark there. I can put a tick mark there. Now I'm just going to connect these 2 points where the 3 inches ended. And there I have my right triangle with 2 congruent sides. They are both 3 inches. Now, you do not need to erase those lines. If you choose to do so, you're a neat freak, you want to get rid of that, feel free to do so. But to me, you have your right triangle with 2 congruent sides. So this would be a right isosceles triangle. All right, for our final example, we have been asked to draw a triangle with the given description. Now there's a lot in this, so let's kind of break it down as we go through it. So it's a scalene triangle with a 3-inch side and a 4-inch side that meet at a 110-degree angle. So now, not only do I have side lengths, I need to account for this angle measurement. So as I break this down, a scalene triangle, that means I'm going to have no equal sides. So I'm just going to write up here, no equal sides. Okay, so if one side is a 3-inch, the other side is a 4-inch, the third side cannot be 3 or 4 inches. It has to be any other measurement. Now I also notice that it's going to have a 110-degree angle. And if it's going to have a 110-degree angle, that lets me know that this triangle is going to be an obtuse triangle because it's going to have an angle that's greater than 90 degrees. All right, so now that I start breaking it down this way, it's going to be a triangle that has no equal sides, and it has an obtuse angle to it, 110 degrees. So let's draw a 110-degree angle that have rays that are 4 inches and 3 inches that come from it. All right, so I think we can do this. So let's start with our vertex. There's my vertex, and I'm going to start with a 4-inch. I like the longer line as my base. So I'm going to use the bottom of my ruler, and as you can see here, 1 inch, 2 inch, 3 inch, 4 inch. So there's my 4-inch base. And I think it's a great habit to label that right away. So there's my 4-inch base. Okay. Now this next part is really important. I just can't guess the length of the side. I have to get the angle measure first. So I'm going to get my 110-degree angle. Notice how I'm lining up my vertex on the base. It's an obtuse angle, so it's going to open this way, and it's going to be 110 degrees. So since I'm opening it this way, I'm using the inside measurements. Okay, so let me get this lined up again. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. I'm not worried about the 3-inch measurement yet. I'm just worried about this angle measure. So again, notice I'm at the 110 degrees. All right. So I'm going to connect the vertex to the 110-degree angle mark. Okay. So I know I have my... Okay. So I've got my 4-inch base. All right. I've got my 110 degree angle. Now with a 3-inch side, again, I'm going to go back to it. I don't mind if you draw your lines too long. So now we need to have a 3-inch side. So I'm going to put my 0 on the inches at the vertex, and I notice that 3 inches, 1, 2, 3 inches falls right here. So I'm going to put my tick mark right there. So that's not where I want to draw for my ruler. I want to go from the 3-inch mark all the way up to the 4-inch line here. So I'm going to connect the 2 points. And here is my 3-inch side length. So, have I met the criteria? It's a 3-inch side right here, and it only goes to this point right here. Okay? It's all right that there's an extra line there. Don't worry about that. I've got my 4-inch side right here. And they meet, so this side and this side meet. So our formal would be the vertex. They meet at the vertex at a 110 degree angle. All right? Now, again, as long as this side is longer than 3 or 4 inches, we nailed it. And it's actually about 5 3/4 inches. Okay? So we did a great job. Okay? So you constructed a triangle with the given descriptions. You were given 2 side lengths and 1 angle measure. After watching this video on triangles, you should be able to construct a triangle with given angle measurements, and you should also be able to construct a triangle with given side lengths.